Welcome to this video. In this video, I will demonstrate how to apply ARDL model in Eviews. Before applying ARDL model, one should remember some basic steps. The first step is to check the integrated level of the data, that is, at which level your variables are stationary, also known as unit-root testing. The second step is the co-integration diagnostic, in which you can check whether or not your variables move can move in same direction or can move together in long run. The third step is the model selection, and the fourth is to estimate the long run and short run coefficient along with speed of adjustment. I have data of 6 variables, and my independent variable is my dependent variable is log of real GDP. The independent variables are log of real gross capital formation, log of real exports, log of real imports, log of real agriculture value added, and log of real manufacturing value added. I'm going to perform the very first step of unit-root testing on log of real GDP. When you click on unit-root test, a dialog box will appear in front of you. Here the first thing is the test type, that which type of test you are going to select to check the stationary level of the data. I'm going to use the default test type, that is the augmented Dickey-Fuller test. The second thing is at which level you are going to test the stationary, whether you are going to test the stationary at level, whether you are going to test the stationary or at first difference or at second difference. For the case of ARDL, there is an assumption that no variable should be integrated of level 2. Calculated these results earlier, so I know that this variable is stationary at first difference. The statistics is minus 7.4640 with the p-value 0.00. That is, we have strong evidence to reject our null hypothesis, which is difference of log of real GDP has a unit root. Now the variable is difference of log of real GDP because we have selected the first difference from that dialog box. You can check other variables, the stationary level of other variables, like that. I have compiled those results for all the variables, and you can see from that table that all the variables are stationary at first difference, and no variable is integrated of level 2. That is, we can apply ARDL on this data. The next step is the co-integration diagnostic to test whether our variables are co-integrated or not. For this purpose, we have to run the ARDL model with optimum lag length, which may be 1 or 2 for the annual data, and maybe 4 or 5 for the quarterly data, and might be 10, 12, or even 14 or 16 for the monthly data, depending on which type of data you are using. For our case, this data is annual data, so we can use optimum lag length as 1 or 2. Following is the equation with optimum lag length 1. In this equation, you can see the dependent variable is difference of log of real GDP along with constant term, and difference of log of real GDP is with first lag, which is our independent variable. The next is difference of log of real gross capital formation with its first lag, then difference of log of real exports with its first lag, and so on. In the end, these are the variables which are used, those coefficients are used to test the co-integration. These are the results, both for view representation. Here you can see that the variables whose coefficients can be used for the configuration, for assessing the configuration. These coefficients are starting from C13 and up to C18. So we can go for fault statistics, coefficient diagnostic, wall test, and here I'm going to paste this equation. These are the results. We can see that F statistics is 5.176. We will compare this F statistics with the bound values provided by Pisaran in his paper 2001. If this value is greater than the upper limit of the bound values, we can conclude that there is evidence of configuration, and if this value is less than the lower bound, we can say that the configuration is not present between the variables. These are the results of ARDL bound testing. 5.176 is the fault statistics, and these are the upper and lower bound values at 10, 5 and 1% level of significance. It can be noticed from this table that the upper bound value at 1% level of significance is 4.62, and our F statistics value is greater than this bound value, so we have strong evidence that the configuration is present in our among variables. Also, the Turbo-Morrison statistics 2.04 and LM statistics indicates that there is no serial correlation among residuals. After checking the co-integration between variables, the next step is to specify the ARDL model. I have already estimated different models with different lag length along with their SIC, Shiva's information criteria, Cake information criteria, Turbo-Morrison statistics, LM statistics, and Ward-F statistics. On the basis of Cake information criteria, I am going to select this model in which this 0 denotes that the difference of log of real gross capital formation has no lag in the ARDL model, in the selected ARDL model, and same for the case of difference of log of real manufacturing value added. Here is the equation that I am going to estimate. There is no there is no lag of difference of log of real DCF and no lag of difference of log of real manufacturing value added. These are the results from that model, and now I am going to extract the long run coefficient. For the long run coefficient, the formula is beta I equals to minus theta I over theta naught, where theta naught is the coefficient of dependent variable, is the coefficient of lag dependent variable, and theta I is the coefficient of ith lag independent variable. For our case, going to representation, theta naught will be C11 and theta I are from C12 to C16. Now I am going to estimate the long run coefficient of log of real gross capital formation. Going to view coefficient diagnostic, wall statistics, minus C12 divided by C11 equals to 0. The value is 0.2765 with t value 5.7477, and the p value denotes that it is highly significant. Similarly, you can calculate the other long run coefficients which I have presented here. These are the short run coefficients which I am going to described now. For short-run coefficient, first I have to estimate the ECM version of ARDL, and for that ECM version I require the error term. Error correction term can be obtained by running a spurious regression like estimate equation. Our independent variable is log of real GDP constant, log of real GCF, log of real exports, log of real imports, log of real agricultural value added, log of real manufacturing value added. Right. 2, 3, 4, 5, 6. Right. You can see that this equation has gave you some results. Now going to residual variable, in which the residuals of the fitted model has been saved. I have already defined a new variable, a new series called arrow, and I have copied these values to there. So error is my error correction term that I can use in the ECM version of ARDL. So I'm going to estimate the short run coefficients of my model. Here you can see that the coefficient of error correction term is minus 0.9566, that is negative, and is highly significant, which indicates that there is a strong evidence of co-integration among variables. The next step is to estimate the short run coefficient. Now the short run coefficient are the summation of all the particular variables which are included in the model with different lags. That is, the coefficient of log of real export, the short run coefficient of log of real export will be this plus this. So I'm going to calculate it by first representing my model, and then going for coefficient diagnostic and for statistics. Now I'm going to calculate the coefficient of log of real export, the short run coefficient of log of real export, which will be C4 plus C5 equals to 0, that is 0.1148. I have already written here 0.115 by rounding off. So you can also calculate other short run coefficients like that. One thing that I have missed is the coefficient of log of real gross capital formation. It is the same coefficient because there is no other variable in lag form of difference of log of real GCF present in the model. So the same coefficient with the same significance has been used as short run coefficient.